This Zoom session is being brought to you by the fractal 5 Roman XW. Okay, we proceed. Okay, here we'll be adding and multiplying and dividing radical expressions. Okay, here's a couple of rules. Product of square roots is the square root of the product. That's because if you square this and get root A, root B, root A, root B, and the root A is multiplied to an A, and the root B is multiplied to a B, so they square root of AB, and therefore the same as root AB. The square root of a ratio is root A divided by root A, root B, a ratio of square roots. Then we can do what's called rationalizing the denominator by multiplying above and below, numerator and denominator, by root B. Okay, assuming B is positive, which is of course necessary for the square to be defined, these multiply to B, these multiply to root AB over B. So ratio of A over square root of a ratio A over B is the square root of AB, that divided by B. And please, when you write this down, please make sure to make the divide sign longer than the square root sign, because in mathematics, ambiguity is not your friend. If we have square root of A squared B, then the largest and the square factor factors out to root A squared, which is absolute value of A. So you can remove a square factor inside a radical. Usually we try to remove the largest square factor. Now, if we have a sum of roots times a difference of roots, well, sum times difference is difference of squares, and root A squared is A, root B squared is B. So sum of roots times difference of roots is A minus B. This is useful for dividing by a sum of roots or a difference of roots. If we have 1 over a sum of roots, we can multiply above and below, numerator and denominator, by root A minus root B. The denominator becomes A minus B like this. And the numerator is root A minus root B. Similarly, if 1 over a difference of roots, well, we multiply above and below by root A plus root B. The denominator again is A minus B, and the numerator is root A plus root B. So this is called rationalizing the denominator, getting rid of square roots in the denominator. All right, here are some simple ones. Root 5d times root 8d. Well, that's root of 5d times 8d. That's 40d squared. Now, the largest square factor of 40 is 4 times 10. Largest square factor of d squared is d squared. So root 4, root d squared, root 10. This comes out to 2d root 10. 2d root 10. Well, to absolute value of d root 10, but for these problems, we'll just assume that all the letters are positive, just to avoid having to write the absolute value signs. Here we have root 5x cubed times root x to the 5th. Well, it's root of their product, 5x cubed x to the 5th. That's root of 5x to the 8th. 5, it's a prime, it has no square factors. X to the 8th, well, that's a square of x to the 4th, so we pull it out. Root of x to the 8th, root 5. Square root of a power is x to half that power, 8 halves. So you get x to the 4th, root 5. 2 root 6 times 3 root 3. Okay, 2 times 3 outside. Root 6 times root 3 is root 6 times 3. So this is 6. Root 18. The largest square factor of 18 is 9. Root 9, root 2. Root 9 is 3. 6 times 3, root 2. And then you get 18 root 2. Here we have 3 root 3 times root 27 minus root 2. What's that? Well, we distribute 3 root 3 over both terms. So 3 root 3 root 27 minus 3 root 3 root 2. Now that's root 3 root 27 multiplies out to root of 3 times 27, which is root 81. So this becomes 3 root 81. Root 3 root 2 is root of 3 times 2, so this becomes 3 root 6. Now root 81 is, well, 81 is 9 squared, so root 81 is 9. So 3 times 9 minus 3 times root 6, or 18 minus 3 root 6. Here we have, oh, this is a FOIL problem. Difference times sum. Root 2 root 3 minus root 3 times root 3 plus root 5. What's that? Okay, first, root 2 root 3, outer root 2 root 5, inner minus root 3 times root 3 here. Last, minus root 3 times root 5 here. Root 2 root 3 is root 6. Root 2 root 5 is root 10. Root 3 is root 9. Root 3 root 5 is root 15. This root 9 is just a 3. The rest have no square factors, so they stay where they are. You get root 6 plus root 10 minus 3 minus root 15. Here we have a ratio of roots. Root 18x over root 25x. Okay, we merge that into a single root. Root of 18x over 25x. The x's cancel. Root 18 breaks into root 9 times root 2. 9/25 is a square of 3/5. So you get 3/5 root 2 here. Here we have similar, but different. Root 27x over root 75x cubed. Merge the roots, so it's a root of a ratio of 27x over 75x cubed. X over x cubed cancels, leaves an x squared in the denominator. Removing a factor of 3 from both 27 and 75 leaves 9 over 25. Then you distribute square roots over everything. Root 9 over root 25 root x squared. Root 9 is 3, root 25 is 5. Root x squared is x. Okay, technically is absolute value of x. But like I said, for these problems, I'll allow you to momentarily forget about momentarily assume that everything is a positive number. Proceed. Five over root 3 plus root 2. We take this ratio and multiply numerator and denominator by root 3 minus root 2. Now, if you have a sum of roots and a difference of roots, these are called conjugates. And multiplying above and below, I call rescaling. So we took this and we rescaled by the conjugate of the denominator. I know in the numerator, you just distribute the 5. You get 5 root 3 minus 5 root 2. Sum of roots times difference of roots will be 3 minus 2, which is 1. Anything over 1, the 1 cancels. So you get 5 root 3 minus 5 root 2. Here we have root 3 minus root a over root 5 plus root a. Well, we take that ratio and we rescale by the conjugate of the denominator. Root 5 plus root a, the conjugate is root 5 minus root a, numerator and denominator. Okay, the denominator, sum of roots times difference of roots will be just 5 minus a. And the numerator, let's see, FOIL. First, root 3 root 5, here is root 15. Outer root 3 minus root a is minus 3 root a. That's minus root 3a. Inner minus root a times root 5, that's minus root 5a. And then last, minus root a times minus root a is root a, which is a. So root 15 minus root 3a minus root 5a plus a all over 5 minus a. 8 over root 7 plus 2. Now, watch out. This is not, it's not written that way, so I have to be a little careful. Root 7 plus root 2. Well, by the conjugate of the denominator. Plus root 7 minus great deal. Please mute your mic. Mailing, please mute your mic. Thank you. All right, I'm muting it. Here's root 15 plus root 2 times root 15 minus root 2. Well, a sum times a difference is a difference of square. Oh, no, I'm sorry. I should have been up here. So here we multiply above and below by root 7 minus root 2. So this in the numerator will be 8 root 7 minus 8 times 2 is 16 right here. A sum times a difference is a difference of squares. Root 7 squared minus 2 squared, that's 7 minus 4 is 3. So 8 root 7 minus 16 all over 3. Okay, now here, sum times difference is a difference of squares. Root 15 squared minus root 2 squared. That's 15 minus 2 is 13. 117 has a product and a difference of the two same expressions. So this is a, what they call them, lookalike problem. Product, it'll be root of 32a plus 2a. That's root of 64a squared. Well, root 64 is 8. Root a squared is a, so we get 8a. Here, root 32a minus root 2a. The largest square factor of 32 is 16 times the 2a minus 2a. Root 16 is 4. 4 root 2a minus root 2a, that's 1 root 2a. So when you remove a common factor of root 2a, we have 4 minus 1. Do keep the invisible 1 in mind. And 4 minus 1 is 3, so you get 3 root 2a. Typical way for people to make a mistake here is to see this and see nothing in front of the root 2a. So you put a 0 here and right away you're off. Okay, that does it for this section.